So we have gx is sin x, domain of g is r, range of g is -1 to 1 here. Now that is, since range of g, which is your -1 to 1, is subset of domain of f, which is your, you can see from here, r, that is f of g exists. Now how to find f of g? F of gx is equal to, that is f of gx. So it can be written as f of sin x, because fx is x square plus 1. F of sin x will be equal to sin square x plus 1. So this is what, that is your f of gx. Now similarly, to find g of f, range of f should be subset of domain of g. So what is range of f? Now you can see here, range of f is 1 to infinity. What is domain of g? It is subset of r. Therefore g of f exists, and g of fx is equal to g of fx, that is your g of x square plus 1. Since g of x is sin x, g of x square plus 1 will be, that is your sin of x square plus 1. So this way we can find f of g and g of f here. So next is for example, the next question is, f is a function defined from 0 to infinity to r. G is a function defined from what is that? It is r to r, given by fx is equal to root x and gx is equal to, what is that? It is minus x square minus 1. So find f of g and g of f. So to find f of g and g of f, first we need to write down their domains and to find their ranges. Now fx is equal to root of x. Domain of f is, that is your 0 to infinity, because square root function cannot take the negative values, so therefore range of f is 0 to infinity. Now gx is equal to minus x square minus 1. Domain of g is equal to r. To find range of g, let, or gx, let y is equal to gx is equal to minus x square minus 1. So this implies that x square is equal to minus 1 minus y. From here, because x square is greater than or equal to 0, this implies minus 1 minus y is greater than or equal to 0. This implies that y plus 1 is less than or equal to 0. This implies y is less than or equal to minus 1. So therefore range of g is equal to minus infinity to minus 1. So we have the domain as well as range of f as well as g function. Now next is to find f of g. Check if range of g is a subset of domain of f or not. What is range of g? It is minus infinity to minus 1. And what is domain of f? It is 0 to infinity. Now minus infinity to minus 1 is subset of 0 to infinity. It is not. Therefore f of gx does not exist, because domain of f is 0 to infinity, range of g is minus infinity to minus 1, not even for a single value this exists, so therefore this does not exist here. Now for g of f, range of f should be subset of domain of g. So where is range of f? Range of f is 0 to infinity. Now domain of g, where is domain of g? You can see that it is subset of R, so therefore g of f exists, and g of fx is equal to, it is g of root x. Now g of root x is equal to, what is that, minus root x square minus 1, which is your minus x minus 1. So this way you can find that is your composite function or function of function. Now next is fx is a function which is your root x, and gx is a function which is your x square minus 1, and we have to find that is your f of g and g of f if it exists. Now you can see that domain of f is equal to 0 to infinity, range of f that is also 0 to infinity, domain of g is equal to whole of the real line. Now for range of gx, now y is equal to x square minus 1, y plus 1 is equal to x square, as x square is greater than or equal to 0 implies y plus 1 is greater than or equal to 0 implies y is greater than or equal to minus 1. So therefore range of g is equal to minus 1 to infinity. We have the domain of f, range of f, range of f, domain of g, and now the range of g. So for f of g to exist, range of g should be subset of domain of f. What is range of g? It is minus 1 to infinity. Now what is domain of f? It is, that is your 0 to infinity. Now you can see here, for some of the values it exists but not for all. So that means we will have to redefine the domain of f of g. So if we are able to define the domain of f of g, then we can find f of g here. Since minus 1 to infinity is not a subset of 0 to infinity, so define the domain of f of g. So how to define here? You can see here, so this is one function, this is the another function. Now f of g, so that means here we have function g, here we have function f. This is x, here we have gx, and here we will have f of gx. So it's very easy to understand what is the meaning of composite function. X represents the domain of g, gx is the range of g, subsequently it is also the domain of f. Now for f of, or you can say that domain of f of g is equal to x such that x belongs to domain of g and gx belongs to domain of f. That is, x belongs to domain of g and gx belongs to domain of f. So what is that? It is x such that x belongs to domain of g, it is R, and gx, where is gx? X square minus 1 belongs to domain of f. Domain of f means that it is greater than or equal to 0. So you can see here it is x such that x belongs to R and x belongs to minus infinity to minus 1 union 1 to infinity. That is, domain of f of g is x such that x belongs to minus infinity to minus 1 union 1 to infinity. Once we have the domain of this, then f of gx is equal to f of gx, which is your f of x square minus 1, so which is your under root of x square minus 1. So you can see here, this way you can have the domain of f of g here. Now next is to find, that is your g of f. Now range of f should be subset of domain of g. Range of f is 0 to infinity. It is a subset of domain of g, that is R. So therefore g of f exists and g of fx is equal to g of fx, which is your g of root x, which is your x minus 1. So this is all about your composite functions. It's very easy. Through the Venn diagram, it's very easy to understand. At least in the beginning, for each and every question, try to form the Venn diagram. Then you will be able to understand each and every problem related to this. Now next is invertible functions. Now, what is the meaning of invertible function? You can see here, f is a function defined from a to b. So if we are able to define a function from b to a, then we say that it is invertible and we denote it with f inverse here. So once again you can see here, if f is a function defined from a to b, and if we are able to define a function from b to a, then we say that it is invertible function and we denote it with f inverse. Now, so what is the definition of invertible function? A function fx is said to be an invertible function if it is both 1 1 and onto. If it is both 1 1 and onto, that is, if it is bijective. Bijective means that is 1 1 and onto here. Now let us discuss this point by considering any example of this. Let S be any set consisting of the elements 1 to 3 and f be a function defined from S to S and defined as, that is your, say the first one is f1 is equal to, this is your 1 1 2 2 3 3. Second is f2 is, that is your 1 2 2 1 3 1. It is 1 2 2 1 3 1. And third is f3 is equal to, it is 1 3 3 2 and 2 1. So we have to see which one of them is invertible function, and if it is invertible, then how to write down the inverse, or to find the inverse and write it as an ordered pair. Now you come to the first one. So through the Venn diagram you can see here that it is f1 1 2 3 here, 1 2 3 here, image of 1 is 1, 2 is 2, 3 is 3. So it is both 1 1 and on 2, hence it's a function here, or it is invertible function. So what is f inverse of f inverse? It will be 1 1, 2 2 and 3 3 itself. Now come to the second one. Now this is your f2 is a function. Now we have 1 2 3, 1 2 3. You can see here image of 1 is 2, image of 2 is 1, image of 3 is 1. So it is many to 1, many to 1, and moreover it's not onto, therefore not invertible. Now come to the third one. Third is, this is f3, 1 2 3, 1 2 3. We have 1 3, 3 2, 2 1. You can see that it is both 1 1 and on 2, hence invertible. So if it is invertible, then what is f3 inverse? It will be from here 3 1, 2 3 and 1 2. So this is the inverse of the function here. So this way we can check whether the function is invertible or not. Now next is if A is a set consisting of the elements 1 2 3 4, B is a set consisting of the elements, what is that, 2 4 6 8, f is a function defined from A to B given by fx is equal to 2x, then write f and f inverse as a set of ordered pairs. So you can see here f of 1 is 2, f of 2 is 4, f of 3 is 6, f of 4 is 8. That is, again you can see through the event diagram, this is 1 2 3 4, this is 2 4 6 8. Now image of 1 is 2, 2 is 4, 3 is 6, 4 is 8. So therefore fx is equal to 1 2, 2 4, 3 6, 4 8. If I have to write down f inverse of x as a set of ordered pairs, it is 2 1, it is 4 2, it is 6 3 and it is 8 4. So this way you can write down f and f inverse as a set of ordered pairs. Now next is how to find the inverse of a function. Now if f is a function defined from R to R given by f is a function defined from R to R is a bijection given by fx is equal to x cube plus 3, then find f inverse of x. Now we have come to know what is invertible function. We can check whether the function is invertible or not. Now the next question is how to find the inverse of a function. So let us take that is y is equal to x cube plus 3. So whenever you have to find the inverse of a function, always write down x in terms of y. Here we have y in terms of x. Can I write down y minus 3 is equal to x cube? So this implies x is equal to y minus 3 raised to power 1 by 3. Now to write down f inverse, simply change y to x and x to f inverse of x. So this is the inverse of a function. Replace x with f inverse of x and y with x. So this is the inverse of a function here. Now similarly, next question is, let's say the next one is, if f is a function defined from f is a function defined from R to R, I'm sorry, it's not R to R, f is a function defined from 1 to infinity to 1 to infinity given by fx is equal to 2 raised to power x into x minus 1 is given to be invertible. Now find f inverse of x. So this function is given to be invertible. So how to find the inverse of this function? So once again, let us take y is equal to 2 raised to power x into x minus 1. So we have to remove this power from that is from here. That is, the exponent is to be removed. So taking log on both the sides to the base 2. Why 2? Because it is x 2 raised to power here. So log of y to the base 2 is equal to log of 2 raised to power x into x minus 1 to the base 2. So because log of m raised to power n is equal to n log m, so this is equal to x into x minus 1 log of 2 to the base 2. Because log of any number to the same base is always 1, so this comes out to be equal to x into x minus 1. So purpose always should be to write down x in terms of y. So this implies, this is your log of y to the base 2. So this implies x square minus x minus log of y to the base 2 equals to 0. So this is a quadratic in x. So using discriminant method, minus b plus minus root b square minus 4ac over 2a. So now you are getting two values of x. One is 1 plus under root of 1 plus 4 log y to the base 2 upon 2. Other is 1 minus under root of 1 plus 4 log y to the base 2 upon 2. Now straight away I can write down the answer. But since I have to explain to the students now how to check, you can see that this represents codomain and the values of y are from here. Let y is equal to 1. If I take y equals to 1, there are two options. X is equal to 1 plus minus now 1 by 2, which is 1, or 1 minus 1 by 2, which is equal to 0. But by taking y equals to 1, I am getting x is equal to 0, which is not part of the domain. If it is not part of the domain, how can you have the inverse from here? So therefore x is equal to 1 plus under root of 1 plus 4 log y to the base 2 upon 2, or f inverse of x is equal to 1 plus under root of 1 plus 4 log x to the base 2 upon 2. So this way you can find the inverse of the function. Now similarly, so the next question is, f is a function defined from R to 0 to 2 given by fx is equal to, this is e raised to power x minus e raised to power minus x over e raised to power x plus e raised to power minus x plus 1 is invertible, and we have to find, that is, this is invertible and we have to find f inverse. Particularly these questions are going to be very helpful in solving the questions for those students who are preparing for competitive exams. Now let y is equal to e raised to power x minus e raised to power minus x upon e raised to power x plus e raised to power minus x plus 1. So this is equal to, if you take the LCM, e raised to power x minus e raised to power minus x plus e raised to power x plus e raised to power minus x upon e raised to power x plus e raised to power minus x. Can this be written as 2 times e raised to power x upon e raised to power x plus e raised to power minus x? That is e raised to power x minus e raised to power minus x plus e raised to power x plus e raised to power minus x upon e raised to power x. So can this be written as 2 times e raised to power x upon e raised to power x plus 1 over e raised to power x, or it is 2 times e raised to power 2x upon e raised to power 2x plus 1. This is equal to y here. So once again the purpose is to write down x in terms of y, cross multiply the terms. Y into e raised to power 2x plus y is equal to 2 times e raised to power 2x. So from here I can write down e raised to power 2x into y minus 2 is equal to minus y, or what is that? E raised to power 2x is y upon 2 minus y. So that is from here e raised to power 2x is equal to y upon 2 minus y. Again, so taking log on both the sides to the base e. Now taking log on both the sides to the base e. So therefore log of e raised to power 2x to the base e is equal to log of y over 2 minus y to the base e. So this implies 2x is equal to log of y over 2 minus y to the base e, or this implies x is equal to 1 by 2 times log of y over 2 minus y to the base e, or f inverse of x is equal to half of log of x over 2 minus x to the base e. So this way you can find the inverse of the functions. Similarly, say the next question is, f is a function defined from r except minus 4 over 3 to r, given by fx is equal to, this is 4x upon 3x plus 4. Show that f is a function defined from r except minus 4 over 3 to range of f is 1 1 and onto, and then hence find f inverse. We have to show that this function defined from r to r except minus 4 over 3 to range of f is both 1 1 and onto, and hence find f inverse. Now for 1 1, let x1 x2 belongs to the domain of f. So therefore fx1 is equal to fx2 implies 4x1 over 3x1 plus 4 is equal to 4x2 over 3x2 plus 4. Now cross multiply the terms, that is your 12x1 x2 plus 16x1 is equal to 12x1 x2 plus 16x2. So this implies that x1 is equal to x2, only implies that the function is 1 1. Now next is, so y is equal to 4x over 3x plus 4, that is your 3xy plus 4y is equal to 4x, or x into 3y minus 4 equals to minus 4y, or x is equal to 4y over 4 minus 3y. So therefore range is whole of the real line except, because this should not be equal to 0, that is your y cannot be equal to 4 over 3. Now so when the function is defined from this to range, this becomes onto. Now therefore f inverse of x is equal to, that is 4x upon 4 minus 3x.